Hello dear learners. Yesterday we have seen the functions of starter cultures, definitions of starter cultures, advantages of starter cultures, and introduction to starter cultures. After the introduction, advantages, definitions, and the functions of the starter cultures, we are going to see in detail the types of the starter culture. The starter culture is classified on the basis of the composition of the microorganisms, that is whether that is the single or the paired or the mixed or the multiple, or the based on the growth of temperature, that is the mesophilic starter culture, or thermophilic starter culture, or based on the flavor production, whether they produce the flavor or not flavor, based on the type of the fermentations. So let's see in detail the classification of the starter culture. That's based on the microflora or the microorganism. The first one is the single. Single means for the fermentation process, just a single type of the microorganism is selected or they added. In that case, that is called as the single microorganisms. Then the paired, it means in this type of the the two types of the microorganisms added. The drawback of the first one, that is the single type of the microorganisms, when the only single type of the microorganism is added, in that case macrophages may attack on that microorganism. So the desirable fermentation process will not be carried out. So in that case, the paired compatible strain is added. It means that the two different types of the microorganisms added. If the any single microorganism is attacked by the phages, the second one remain as it is, or second one remain live. So the second microorganisms carry out the further fermentation process. In this way, the desirable fermentation process is carried out. Whereas in the mixed strain is again mixed strain means the more than two organisms which may have the different characteristics like acid production, flavor production, slime production, etc. in unknown proportion are used. It means that here in this type of the classification, more than two strains are used, and they have the different characteristics like the acid production, the flavor production, or the slime production. And whereas in multiple mixed strain, here also more than two microorganisms are used, but their quality and their behavior of these strains is predictable. Whereas in the mixed strains, their quality and their behavior is unpredictable. So this is the difference between the mixed strain and multiple strain. So this is the classification which is based on the microorganism, that is the single strains. Single strain means here the only single strain is used. Here only the single microorganism is used. Whereas in the pair, it means here the two microorganisms are used. Why here the drawback of this single strain is that when the macrophages is attacked on the single strains, so the desirable fermentation will not be carried out. Whereas in the paired or compatible means here the two different organisms are used. If the one microorganism is attacked by the macrophages, then the second microorganisms carry out the fermentation process. So the desirable fermentation is carried out. In
mixed trays, more than 2 microorganisms are used. And here why the more than 2 microorganisms are used? These more than 2 microorganisms are used for the different purposes. It means the acid production, the flavor production, and the slime productions. Whereas in multiple, the mixed and multiples are same. Just a little bit difference is there. In multiple mixed strain, their quantity in multiple mixed strain, their quality and their behavior is predictable, whereas in mixed strain their quality and behavior is not predictable. Second one is the based on the growth of temperature. This starter culture is classified in 2 different types, that is the mesophilic starter cultures and the thermophilic starter culture. The difference is in their temperature, in which temperature their behavior or the fermentation process is very good. In mesophilic starter cultures, they require the temperatures, that is the 22 to 40 degrees Celsius temperature. Into these temperatures only they functions very well, whereas the thermophilic starter cultures, they require the temperature that is the 32 to 45 degrees Celsius. It means that they work very well at this temperature. Based on flavor production, the next classification which is based on the flavor production, and these microorganisms are classified in B type, D type, BD type, and N type. In B type, Leuconostoc, this classification is generally based on whether this microorganism produces flavor or not. In this, in B type, the example for the B type is Leuconostocs, and they produces the flavor. Where in D type, Lactobacillus lactis subspecies lactis, and in BD type, mixture of both, that is the B and D. Whereas in N type, in this these microorganisms which are placed in N type, they do not produce the flavor. So these are placed in N type. So this is the classification which is based on the flavor production. The next classification is based on type of the fermentation, that is the homo or hetero, and it is also based on the end products resulting from the glucose metabolism. The example of homo fermentive cultures is Lactococcus lactis subspecies lactis, and the example for the hetero fermenter, that is the hetero fermentative cultures, example Leuconostoc dextronicum. So this is the classification which is based on the microorganisms, whether that is a single, double, or a mixed, more than 2. This is the based on the temperature, whether that is the mesophilic or thermophilic. Mesophilic starter cultures require the temperature range, that is the 22 to 40 degrees Celsius. Thermophilic starter cultures requires the temperature, that is the 45 degrees Celsius. So on this basis, this classification is based, and then the flavor productions, whether they produces the flavor or not. So they are again classified into 4 different types, that is B, D, BD, and N type, and based on the type of the fermentation. So this is the these are the different types of the starter cultures, and these are classified on the basis of their characteristics. Now the next point is the propagation of the starter cultures, which is also the very important one. And propagation of starter cultures is very important in case of industrial point of view. And why it is so necessary to propagate the starter cultures? The quality of the final product or the quality of the fermented product is totally depends on the starter culture used for the fermentation process. And if this starter culture is of not having the superior quality, then we cannot expect a superior quality product from the such a inferior quality of the starter culture. Therefore, it is today's need to propagate a starter culture which is having the superior quality. Starter culture, as we have seen, it's a very important for the industrial point of view, and when we are selecting the starter culture, that starter culture must have some characteristics like it must be active. That starter culture must be active, must contain the maximum number of viable microorganisms, means it contains the maximum number of viable uh, microorganisms. Then must be free from the contaminants. It should not have any contaminants or the contaminations. And to obtain the above characteristics, above quality starter culture, the inoculum or the inoculation is carried out under the aseptic conditions. So when we are starting the process of the propagations, so to achieve the objectives of the superior starter culture, the process of addition of the starter culture, that is the process of the inoculation, should be carried out at a aseptic in a aseptic condition. Then again, whole process, that is the propagation process of starter culture, that must be initiated in a sterile medium. So these are the few points. That points must be. Now we will see the propagation of a starter culture. We have already seen the importance of starter culture, why the starter culture is important. Starter culture is very important for the industrial point of view. The quality of the final product, that is the fermented milk product, is totally depends on the quality of the starter culture used for the fermentation process. So in this point, under this point, that is the propagation of starter culture, we will see the method of the propagation of starter culture. The first point is the treatment of milk. The milk plays medium for the propagation of the starter culture, and the milk is taken. Why the milk is taken? Because milk plays the very important role to provide the nutrients to the starter cultures, the microorganisms which is used here. Okay, so for this purpose, the milk is taken. The milk is, the first point is the selection of milk, and in that is the treatment of milk. Or the which milk is selected. The milk of first grade should be selected. The milk which is having the first grade, only that milk should be selected for this purpose. Then the milk which is abnormal quality, that milk should not be selected. It means that the milk which is taken from the mastitis cow, that milk should not be used. The milk is not used which is the last. It means the late lactation milk should not be used for this purpose. Then the milk which is which contain the antibiotics, that milk also should not be used. Then again, the milk which is having the bacteriophages, that milk also should not be used. So after selecting this milk, that milk is allowed for the treatment. And why the milk is subjected for the heat treatment? The treatment of
milk is very important to inactivate the bacteria present in that milk, previous bacteria present in that milk, to inactivate the bacteriophages present in that milk, or to inactivate the germicidal properties of that milk. And after the treatment of milk, a process is carried out, and the name of that process is tenderization. In this process, or in this step, reconstituted milk is taken, and it is divided into the different lot. Reconstituted milk is divided into the different lots, and these lots are kept as it is for a day, and then it is examined whether there is the curdling present in that or not. If the curdling is present, that lot is removed. Then the second lot, third lot, fourth lot is observed. If the curdling is not present, then again it is heat treated, and then again it is kept as it is for a day. Then again curdling is checked whether there is any curdling or not, and if the curdling is present, then again that lot is removed from this. Then again the heat is given for that lot. If and then again it is kept as it for a day, and again the curdling is observed. If the curdling is not observed, then this skim milk is used for the further process. The step of again and again checking whether there is any curdling present into that skim milk. This process shows there is there is absence of any kind of the bacteriophages into that skim milk. So only that kind of the skim milk is taken for the further process. And then the next step is the inoculation. The next step is the inoculation. Inoculation is nothing but that is the addition of the starter culture to that treated skim milk. And inoculation is preferred with sterilized equipment. Inoculation has to be carried out in a separate rooms with ultraviolet lamp designed for this purpose, or by using the laminar flow system. Freeze-dried ampullae is sterilized with alcohol, and liquid culture tubes are shown to flames. The amount of the inoculum depends on the activity of starter cultures, temperature, and incubation, and the time of the incubation. Normally 0.5 to 2% is used, subject to the variations depending upon the situation. So this is the process of inoculations. Inoculation is nothing but it is the process of the addition of the starter culture, and generally 0.5 to 2% of the starter culture is added to that treated skim milk. And after the inoculation process, the next step is the incubation. Incubation is nothing but the keeping the inoculated skim milk at a particular temperature, whether that is the thermophilic bacteria or the whether that is the thermophilic microorganisms or the mesophilic or microorganisms, and their temperature is maintained. A particular temperature is maintained. For the mesophilic organisms, the temperature is 21 to 22 degrees Celsius, and it is kept for 14 to 16 hours. And for thermophilic organisms, it is 41 to 43 degrees Celsius, and it is kept for 3 to 4 hours. Change in temperature may affect the composition of starters in the mix population. So this is all about the incubation. And after the incubation process, the next step in incubation step, the next step is the cooling of the starter. After the incubation, the culture is cooled to stop the further development. The refrigeration appears to give the appropriate cooling effect. So the after the incubation process, after the incubation process, it is stopped for the further fermentation, and it is cooled. Uh, so this is the flow diagram for the propagation of the starter cultures. The first one is the treatment of milk, second one is the inoculation, third one is the incubation, and the last one, that is the last but not least, that is the cooling of the starters. As we have already seen in detail the treatment of milk, why the milk is treated. The purpose of the treatment of the milk is to kill if any bacterial phages present into that skim milk. And the process of treatment of milk is that the skim milk is divided into the different lots, and then each lot is observed for about 3 times whether there is any curdling. Before observing the curdling, that skim milk is heated, and then it is kept as it is, and then the observe whether there is a curdling. If the curdling is present, then that lot is removed. So by this way, the treatment of milk is given, and after giving the treatment, and if the curdling is not observed, that skim milk is taken for the further process, and into that skim milk, the inoculation, that is the up to the 0.5 to 2.5% of the starter culture is added, and then it is incubated, whether that is the mesophilic or the thermophilic bacteria. Their temperature is maintained, and they kept at a particular time temperature combination. And after the incubation period is over, then it is cooled. And to avoid the further fermentation process. So in this way, the starter is propagated, and that is used at industrial level, or this may use at household level. So this is all about the propagation of the starter culture. Thank you very much.